Hello students, welcome to Notebook video lesson. Today we shall discuss the chapter Distribution of Oceans and Continents. In today's discussion, we shall learn about the continuously changing positions of the oceans and continents. Isn't it interesting to know that oceans and continents were once situated differently, and that years down the line, our world map will look different from what it is today? But how do we know about the possible shifts of the continental land masses? Let's find out. The theory of continental drift was put forward by Abraham Ortelius, a Dutch map maker, in the year 1596. The theory suggests that the continental land masses have moved over time, thus drifted apart from one another across then ocean beds. This theory was later developed by Alfred Wegener in 1912. Wegener suggested that there once existed a single landmass called the Pangaea and a mega ocean called the Panthalassa. However, with time, the Pangaea began to split and broke into two large land masses, Laurasia and Gondwanaland. Laurasia and Gondwanaland have further split to form several continents and land masses as it exists today. Today, we have several evidences in support of the continental drift, but when it was first proposed, the theory was met with outright rejection. Let's look at some of the evidences that support the theory, continental drift. Evidence in support of the continental drift. Wegener was a meteorologist who was intrigued by the interlocking fit of Africa's and South America's coastlines on the map, the presence of same-age rocks on the Brazil coast and the Western African coast, and the marine deposits on the coastlines of these two continents suggest that once the ocean did not exist where it does today. The tillite deposits are sedimentary rocks, formed glacial deposits. The Gondwana system of sediments found in India is similar to those found in land masses of the southern hemisphere. The distribution of fossils which show that identical species of plants and animals are found on either side of the ocean barriers indicates that a single large landmass existed. Wegener had suggested that the tidal force and the rotational force caused the continental movements. However, this was considered implausible by his contemporaries, and the theory was thus rejected. Post-World War II, new information has been added to our existing studies on this drift. Let's see what these are. The convectional current theory of 1930s by Arthur Holmes suggests that the system of convection current operating at the mantle level of the Earth helps in the mechanism of movement of the Earth's crust at the surface. The detailed mapping of the ocean floor and the presence of several relief features, including mid-ocean ridges, similar rocks on either side of these ridges, and mountains, suggest that it is not just a vast plain. Now, isn't this interesting? Let's look into this topic of ocean floor configuration in details. The ocean floor may be segmented into continental margins, deep sea basins, and the abyssal plains and mid-ocean ridges based on the depth and the relief forms. Continental margins are transitions between continental shores and deep sea basins. They include continental shelf, continental slope, continental rise, and deep oceanic trenches. The abyssal plains are underwater plains on the deep ocean floor where sediment get deposited. Mid-ocean ridges is an underwater seafloor mountain system. It has a central rift system at the crest, a plateau and flank zone along its length. Let us take a look at a few more facts which were revealed by the mapping of the ocean floor and paleomagnetic studies of rocks as part of the post-drift studies. Volcanic eruptions are common along the mid-oceanic ridges, and this brings up a huge amount of lava to the surface. The rocks of the ocean crust are much younger than the continental rocks. The rocks on either side of the crest of mid-oceanic ridges show similarities in terms of chemical compositions, magnetic properties, and also their period of formation. The sediment layer on the ocean floor are unexpectedly very thin. The sediment column was found to be younger than 200 million years. This supports the deduction that ocean floors are not as old as the continents. The earthquake occurrences in the deep trenches are more deep-seated than the ones of the mid-oceanic ridge areas. These facts and the analysis of the magnetic rocks found on either side of the mid-oceanic ridges led to American geophysicist Harry H. Hess proposing the sea floor spreading hypothesis in 1960. According to Hess's argument, continuous eruptions at the crests of the oceanic ridges causes the oceanic crust to crack. Lava squeezes through these cracks and in the process pushes apart the crust, causing them to drift apart. This theory played a major role in the development of the plate tectonics theory. We shall soon continue our discussion of plate tectonics in the next part of this video lesson. We shall conclude the first portion of our discussion here. See you soon.